Hey guys, so we're at Mooresville Dragaway today, testing our Raspberry Pi OBD Logger projects for motorsports instrumentation class. Been working on these for a couple weeks. Today's the day to test everything, so we're going to show you a little bit about what our project consists of, and then take this thing for a pass and see what kind of data we get.
This logger along with the OBD2. Hopefully it'll work. Air getting pulled. It shows it's working. Let's see if we got any data. No data. Don't know why it's not working when it shows it does. Here we are about to make another run, trying to run this GPS and OBD log. Let's see if we can get this thing to work this time. Says it's logging. Let's see how we do in this next run right now. Not sure what's going on. Some data. It's actually working. Whoop. That was just logging our code. Here's the data. It's only the OBD2 data couldn't get the GPS to work. Here's all the OBD data from the run.
Alright, we're back from the drag strip after a pretty successful day of testing. First time for me, so it was a little bit of a learning curve, learning the light, learning how everything worked in a strip. What was really helpful to have was a checklist we brought with us. It's posted on our Canvas page for school, and we went through the day before we brought everything. We made sure to follow this. We had our data logger tested, our logger packed. We brought our LCD screen, our wireless keyboard, mouse, all the cables we needed to hook up everything, including the OBD cable. We had our logger charged, brought the laptop, brought duct tape just in case we needed. We brought a helmet. I used this for a little go-kart racing, and it worked perfectly at the drag strip. In addition to that, we brought a little bit of money, had our test plan prepared on how many runs we were going to try and make, the adjustments I wanted to run through, brought some tools, a camera, took pictures, took video. So we've got a lot of great data to look back on. We ran a GoPro camera on the roof, so we'll have some of that to show. We also took some in-car camera. So after a few runs, we've got 2 winner slips. This first one, we ran an 11 .8390 eighth mile time. After that run, I wanted to make a change. I felt a little bit of wheel slip off the line, a little bit of chatter just as soon as I got back to the gas. So in order to combat that with the front wheel drive car, I took a little bit of air pressure out of the 2 front tires. I took 2 pounds out. Went back, ran again. Didn't seem to have as much wheel slip, and ended up running an 11.3027. Felt a lot better with a little bit of air pressure out of the fronts. Looking back at it in hindsight, the slower time came out of the right lane. The quicker time was out of the left. So it would have been probably a good thing to run 2 passes in each lane with both configurations of air pressure just to see for sure. But it did feel better when the car took off with lower air pressure, so we'll say that was a successful change. Now we've got our data to go back in and look at inside. Let's go take a look at what we have.
Hey guys, welcome back. This is John. I'm going to go through the actual build process of the data logger along with some of the problems that we encountered along the way. So to start off, we start off with a Raspberry Pi. This is the actual brains of the whole system. Along with the Raspberry Pi, to get the data from the vehicle, you have to hook up the OBD2 cable to it. You have the power cord hooked up to a 2-volt power supply, like a charging outlet in your car, along with a GPS sensor to collect all your GPS data. Not pictured here is the screen we used, and I believe that's it. Some of the problems that we had with it was, at first we couldn't get it to log the GPS data. Not sure exactly why. Sometimes it would, sometimes it wouldn't. I'm thinking more of the problem with that was a lot of the environment that we were in couldn't get a clear signal to the satellites. So the program that we used was the OBD GPS log.py. That program logs your RPM data, your mile per hour data, your throttle position, your engine load, your fuel status, along with your latitude and longitude GPS position. So the procedure that we used to log the data, I rode alongside of Eric in the vehicle. He was driving, I was the passenger, and whenever we were staging in the staging lanes, whenever we were pulling up to the light, to the starting line, I would set up the program, and before we started the run, I would initiate the program and start the logging. And once the run was over, I would go ahead and stop the program and save the data. The Raspberry Pi and the sensors. The Raspberry Pi we had it sitting on top of the cup holder, and the GPS sensor was mounted on top of the car. An ideal position for the Raspberry Pi with the SenseApp would be somewhere very stationary and level. That way it gets a good reading for all the data collected on the SenseApp.
So this is our raw data from one of our runs. We got most of the main attributes that we were looking for in order to tell how the car was running. We got time, RPM, miles per hour, throttle position, load, fuel status, and latitude and longitude. So by processing this data, by using an Atlas program, we're able to use an Atlas viewer and be able to look at a throttle trace, speed trace, RPM of our run, and learn a little bit from how we ran. So this is using Atlas Viewer, Atlas Express. We have the RPM, miles per hour, throttle position, load, and latitude and longitude viewed here on a waveform graph. So as you're scrolling along, right now you're in a zone in the staging area. You're not moving. Maybe at most you may register single-digit miles per hour, but you're staying under 10 that just comes from a little bit of error in the sensors. If you move over closer to the right, you'll start to see tip in. Right at this point in our data is when you tip in and you increase your throttle. Full throttle from the Honda's OBD sensor reads 78.82%. And idle position, if you back up just a little bit, it says 14.9%. So there's a little bit of offset in the throttle position. That's not uncommon to see. That's expected. I was expecting a little bit higher percentage for full throttle, but if you go to full throttle, you're reading about 78.82% with 100% load, as expected. Right there, you see increase in miles per hour with some jumps, a little bit of noise in the data. Obviously, we're not hitting 125 miles per hour right there. We're still accelerating close to 50. In this section, right here, we see a little bit of noise in the miles per hour, a little bit of fluctuation up and down. We're going to attribute that to a little bit of wheel spin, a little bit of chatter. And this was the log that we had before we made the change in air pressure. We don't have a log from our change afterwards, but from the driver feel and from the lap time, we cut out a lot of that wheel spin off the line. So this noise, this chatter that you see here is most likely gone away in the next run. So with only having our one log run of data before we made an air pressure change, we weren't really able to confirm the change in the data with the improvement of reducing air pressure on the front wheels. But what we can do is confirm the driver felt that wheel chatter. You can see that in the data with the miles per hour fluctuation. But what we can do is show that the lap time down the drag strip doesn't lie. With the reduction in air pressure, we went from an 11.8390 to an 11.3027. So while it wasn't a different lane, it would have been great to try that in the same lane. We're going to say that our air pressure change was successful as assumed it would be, with increasing the contact patch and increasing the grip level. In conclusion, our OBD data logger with the Raspberry Pi was pretty successful. We fought a couple things, battled a little bit with GPS data. Didn't learn a whole lot from our GPS sensors or really from the Sense hat on the Raspberry Pi, but the OBD data was great. That was super cool to look at. Our miles per hour trace, RPM, and throttle. We learned a lot from that. We were able to relay, we were able to compare with the driver feel and really be able to see that on a waveform. We saw a little bit of wheel chatter in the speed, and it was cool to see the RPM increase as the throttle position stayed at full throttle going down the drag strip. So overall, pretty successful project. I was really glad we got one run of data at least. Would have liked to have more, but one is cool to look back on. So it was a great time to drag strip.